Is my condition due to diet and lifestyle, or is it due to genetics? You know, that's a question that's been asked over and over through the years. People wonder, is it nurture or is it nature? Is it a result of my internal workings, that is to say, the genetic code, the way I'm put together in there? Or is it a result? Are my health issues, my mental issues, all the issues that I face in life, are they a result of the environment, or is it kind of a combination of both? Well, the emerging science of epigenetics may be shedding some light on that question, as well as on the questions surrounding a biblical topic we're going to look at a little bit later. But first, before going to that biblical topic, let's have a little biology lesson. As you can see, we have some terms on the board here that have to do with biology, that have to do with genetics and DNA and all of those things. I'd like to go over here, and I'm hoping this, I'm picking up here. If I'm not, let me know. Give me a signal back there so the people on the webcast can hear me. But here we have a strand with this excellent piece of artwork. I'm sure you recognize it, especially if you took biology classes, and most of us do recognize this as a strand of DNA. And of course, within this represents the human genome, and within this contains, we find all the information, all the entire blueprint that makes you what you are. In other words, if you had a cloning machine and you wanted to have, you wanted to clone, say, Buddy Brown there, can you imagine the second one? Faye has a look of horror on her face. But if you wanted to clone Buddy, you would have to take something from his cell. Just one cell would do it. But you'd have to take this information from his cell, plug it into the cloning machine, and then produce a second Buddy Brown, as horrible as that may sound to Faye. Just kidding, Buddy. But in any case, this does contain all the information that is needed to maintain you, to keep you going, to keep you what you are. Now, how is it, in spite of all these tons of information here, you know, this little DNA strand contained in a tiny little cell, and you know, the thing has to be wound around a protein structure called a histone in order to fit inside the cell. But it has all this information, and we understand from the Human Genome Project that there are at least 25,000 genes that this thing is made up of. And all this information that's in here, how in the world does it know how to make, for example, new heart tissues? Of course, it doesn't really know anything, but you understand my use of the word here. How does it know? How does it how does it do that? For example, we know that throughout the body, throughout our lifetimes, that we're always, our cells are always getting old and dying off, and they have to be replaced by new cells. And there's a process of cellular regeneration or cellular division that takes place where old cells die off and new cells are formed. And of course, the genetic information, all of this information here, must be copied, just like you're copying a file on your computer, has to be copied, transferred to the new cell, and then you have a new, for example, heart cell, or kidney cell, or liver cell. But how in the world does it know how to make a heart cell out of the proteins that's circulating through the bloodstream, rather than, say, a liver cell? You have some heart tissue that's, you know, some cells there that need to be replaced. How does this thing know how to replace all of that and renew it? Well, the fact is, this is your, think of this as your hardware. All it has is the information. It does all the work, but it only has the information. But you have some software that tells it what to do. And that's where we come to the epigenome. The word epigenome literally means above the genome. Some describe it as a second genome, or in addition to the genome. And what this guy does here, it tells what the software does, it tells the hardware what to do. So for example, if you have some aging heart tissue and you need some new heart cells, then what these methyl groups do that are part of the epigenome is that a signal comes to them, or comes to the epigenome, to tell the epigenome that there's a need for new heart cells. And so these guys here, the methyl groups, what they do is they come over here and they methylate everything all the genes that do not have anything to do with making new heart cells. Now, methylate, let me explain a little bit of that. Bear with me as I use some highly technical scientific terminology here. What that means is these guys serve as the bubble gum that stops up the leaks. That's what the methyl groups do. Now, they're made up of hydrogen and carbon and other compounds, and the function there is to actually turn on or off genes. All of these little things here represent the genes, and they have to be activated or deactivated. And so when you have all the genes that are involved in making heart cells, you want them activated, but what you have to do, you have to shut off all the cells, all the genes that do not have anything to do with making heart cells. You don't want to make skin cells to put them in your heart. You don't want bone cells in your heart or bone cells in your brain. Then they'll really call you bonehead eventually. So that's how this works. Now the methyl groups, as I say, you could think of them as the on and off switches. But there's this other aspect of the epigenome called the histones, and these are protein structures around which the DNA is wound. And if, as I said earlier, if they were not wound around the histones, then they wouldn't fit inside the cell. So they have to be wound like that. These also, the histones also play a part in regulating genetic expression. The tighter they're wound, and the histones control that, the tighter the winding is, then the less the expression. The looser, then the more the expression. Now, to give you an example of that, have you ever, I'm sure most of you here have watered plants with a water hose before, potted plants. Some of them are big, some of them are small, so you turn on the water, you start watering plants. The big potted plants, well, they're easy. Get to the small ones, and if you don't turn down the pressure, you're going to knock them over. So what you do, rather than going over and turn down the pressure, you probably bend the hose, pinch it just a little bit, just enough to turn down the pressure, and let it drip into the small potted plant. That's what the histones do. They turn it up or turn it down. Now, of course, you can look at all of this, and you can say, isn't evolution just wonderful? Naturally, I cannot look at this and consider this process, and by the way, this is the overly simplified form I'm giving to you today. If you get a genetics textbook and start reading it, you're going to encounter words about that long and whole sentences full of such words, and in about 5 minutes it's going to give you a terrible headache trying to understand it. It's very complex, so we're looking at the simplified version today. But, the side note here is that I cannot possibly believe, I cannot muster the faith to believe that all of this happened by sheer chance, a series of accidents, as it were. So when it comes to the Darwinian faith, I am an incorrigible unbeliever. I have to believe that this is the product of design, intelligent design. In other words, God made it this way so that you and I could exist and worship Him and have fellowship with Him. Now then, there's another way of expressing, or another illustration we could use to kind of explain this. Suppose this is a paragraph here, and all the letters, all the sentences in this paragraph represent all the information at the cellular level. All your information is contained in the paragraph. And that means that if you have an identical twin, then all the information in the paragraph in you and your identical twin would be absolutely the same. The letters, the sequence of letters would be identical. Identical. Now, have you ever noticed an identical twin? How many of you have met identical twins before? Most of us have seen them, have talked to them, and isn't it amazing how much alike they are? Sometimes you look at them, it's hard to tell them apart, and you look at them and you see not only do they look alike, but also they have many of the same expressions, they laugh the same way, they have the same mannerisms. Now, some of those things may be learned behavior that they picked up from their parents, but a lot of those things, I would say, go right back to the genes. They come from the genetic level. I would say that at least some of those things go back to the genes and to the information here. But have you ever noticed that oftentimes as identical twins grow older, that they become different? One, for example, his hair may gray earlier than the other, or become thinner before the other does, one may be about an inch or so taller than the other. And they start to change and they grow further apart in how they look and how they behave. And also one may develop a disease that the other does not. Well, there's a reason for that. You wonder if they're so identical, if the DNA is exactly the same, if the genes are exactly the same, how could they start to be different? Well, you see, there was a time when we thought that this told the whole story. We thought that this was the whole story right here, but now we understand that it is not by a long shot. And the science of epigenetics is really still an emerging science. We're just now beginning to really understand it. There's so much more to understand about it. But anyway, the epigenome acts on the genome to bring about certain changes, and that accounts for some of the differences between identical twins. Now, an example of that is a pair of twins, or actually some twins, some identical twins, two ladies. Some years ago, they grew up, everybody was amazed at the similarities. They grew up together. They got to be, I guess, about 40 or so. And they still laughed alike. They even had an inclination to dress alike, to wear their hair the same way. They were just so much alike, and you could hardly look at them and tell them apart unless you knew them really well. And then one of them got cancer. Only one of them got cancer. And they discovered that there was a gene that this one, and actually, of course, the other one as well, a gene that they had inherited from one of their parents that predisposed them to this particular kind of cancer. So that cancer was genetically related. It came from a result of having this gene. So naturally, if you're an identical twin and your sister, your brother, your sibling has cancer, and it comes from the fact that there's a gene that predisposes you to cancer, what are your thoughts in addition to your concern for your sibling? You know that you're going to get it. You're sure that you're going to get it. So in this case, the one sibling who didn't get the cancer at the time the other did waited and waited and dreaded and had checkups, and guess what? It never happened. Never got the cancer. Why is that? Well, the answer lies in the software acting upon the hardware. Somewhere along the way, this lady adopted a different lifestyle. It may have been something as simple as diet. It may have been something as simple as having more B12 and folic acid in the diet. But what happened was something in her diet and her lifestyle, something acted upon the epigenome, resulting in these guys here, the methyl groups or a methyl group, coming over to this gene and blocking it, deactivating it. So she doesn't have to worry about cancer because the gene that predisposes this couple to, this pair to cancer has been shut down, turned off. Now this emerging science is going to lead, and has already led to some therapies that are working, and probably is going to lead to some more in the future where we can begin to control what is going on here because of our understanding of the epigenome. Now, rats have been experimented with. Of course, understanding about what happens at the genetic level with humans comes a little bit more slowly because we don't grow human laboratory creatures in order to experiment on them. We don't grow humans for the laboratory. We do rats and mice. And it's certain that rats and mice, by influencing the epigenome, you can make genetic changes. You don't change anything in the DNA. The genes are still the same, but you change genetic expression. Whether and to what extent various genes are expressed. You can change that through dietary manipulation, lifestyle manipulation, and so on. It was found that a couple of laboratory mice, they were twins, they were identical twins, and yet one of them was a brown, slim mouse, and the other was a big, obese yellow. One was dark brown and slim, the other was large, very large, obese, and yellow. And yet they were identical twins. Identical twins. Now how is that? that these two mice could be born that way. And the one, of course, that was obese and yellow was more predisposed to cancer and diabetes and other metabolic diseases than was the other. Well, because they had a certain gene that in one of the mice, that normally, under normal circumstances, that gene is blocked. The methyl group comes here and blocks the gene. In the other mouse, because some substances was introduced into the mother's diet, the other mouse did not have this blocking of the gene going on. So it was full blast, you might say. Wasn't shut down. And so the result was obesity and predisposition to certain cancers and diabetes. Now, there are many other examples we could talk about of things, of laboratory experiments that have been done, but a growing body of evidence indicates that humans are very much like mice and rats in the lab in this regard. We know it's true of mice and rats, we know it's true of plants, and all the evidence now seems to indicate, and a growing body of evidence indicates that it's true of humans, that the epigenome influences the genome, and therefore, even though the genes do not change, genetic expression changes, and this has a profound effect on the health and well-being of the individual. And some of these things, by the way, can be reversed. So that's what we're beginning to see, beginning to understand. Now here comes the scary part. Here's the scary part. Understand that when the epigenome, when the methyl groups act on the DNA, act on the genes, that they tag them. Now suppose you have a smoking habit, 5 packs a day for 20 years. Well, this may result in the methyl groups reacting in a way that they're not supposed to react. You've introduced some toxins into the system and now they're not acting like they're supposed to. Now when this particular gene was supposed to have been methylated, it didn't get methylated. This one got methylated. And the result is you wind up with cancer or diabetes or some kind of terrible disease. And then, of course, some of the tags are good and some are bad, depending on what happens here. The methyl groups, as they methylate the various genes for good purposes, then these genes are tagged. And of course, we know that going through life, the various phases of life, this is a constant process going on and going on always. And that we have these tags. They come and they go. They're cleared away and other tags replace them. Because you have, you go through early childhood and the developmental process and puberty and adulthood and so on. So there's a constant changing of the tags. Now that it was always assumed in times past that when you passed on your genetic information to your children, you and your spouse, both of you pass on genetic information to your children, it was always assumed that all these little tags that you had accumulated over time were wiped clear so that your child would have a fresh start and he could start forming his own tags. Well, that is generally true. Most of those tags are wiped clean. The slate is wiped clean, as it were. But what now is being discovered is that not all of them are. Not all of them are. Sometimes 1 or 2 tags, maybe more, we don't know yet. Like I said, this is still an emerging science. But from time to time, tags will be transferred. What that means in practical terms is that your grandmother's diet of Twinkies and French fries may result in you getting diabetes. That's pretty scary to think about, isn't it? It's pretty scary to think about the responsibility you have to take care of yourself. Now, of course, the Twinkies and French fries diet was not good for Grandma. Not good for her at all. It affected her health. She died at 97. It finally got her. But she passed on some genetic information, including a tag or 2, that now you have, and you are predisposed to diabetes. So it says our responsibility to our own health may extend beyond ourselves. Now this opens a door to some other things. Like I said, we don't fully understand everything yet. We don't understand everything yet about this process about the epigenome and the genome and how all that works. We do know that there are epigenetic tags that are added to the DNA and causing or affecting the way they're expressed and whether they're expressed. But we don't know everything. There may be some things that are passed on that we're not aware of yet. Now, I think about behaviors. I think about certain behaviors, for example, a proclivity towards sinful behavior. And there is at least some body of evidence to indicate that certain behaviors are genetically linked. That is to say, some have studied, for example, the brains of serial killers and compared them with the brains of ordinary people. Some have studied the brain of pedophiles, compared them with the brains of ordinary people, and have found that there is a structural difference. And if there is a structural difference at the level of the brain, then that means that genetics may play a role in these proclivities. Now, this doesn't excuse anybody from sinful behavior. What it does, it just says that proclivities, inclinations, may be genetically linked. Still doesn't excuse you if you commit the act. There's a difference between the behavior itself and the proclivity, or the feeling, or the drive, or the preference. So all of this may be genetically related, and that leaves open the possibility that some of these things could be passed on to the next generation. In fact, the second and third generations would ring a bell. I didn't finish this example here. Let me go ahead and do it. This is another way of illustrating this process of how the epigenome acts on the genome. Again, this is the paragraph that represents all the information, the blueprint that makes you up, that's in your cells. And if you have an identical twin, then you have the same order of letters. The letters are the same, identical. That is to say, the sequence is the same. Nothing changes. And if somebody could look in there and look under a microscope and see this paragraph, they'll see all the letters lined up, and one will look just like the other as far as the sequence of letters. Now, what does the epigenome do? The epigenome, due to influences in the environment acting upon it, then does not change the sequence of the letters. That remains the same. What it does is punctuates. It adds punctuation and spaces. Now, let me give you an example of how adding a single comma and a space can change the meaning of a sentence. You take the sentence, "What's that in the road ahead?" You add one comma and one space, and you have, "What's that in the road? Ahead?" See how it changes the meaning. And so when you have the epigenome acting upon the genome, it doesn't change the sequence of letters. That remains the same. But by adding spaces and commas and periods and things like that, changing the punctuation, some words become meaningless, or some parts of the sentence may become meaningless. Other things take on new meaning. And so that's an analogy, or that's an illustration to kind of help you understand how all of this works. Now then, I'd mentioned that this is related to some biblical topics, and I'd like to get on into those. I'd like to go to, first of all, I'll say this. For years, I resisted and rejected the doctrine of original sin because I always insisted that Adam's sin and the trauma he experienced as a result of his sin could not possibly have changed his genes. So how is it that we could inherit a fallen nature from Adam? I didn't see how that could work because I knew that a moral failure could not result in changing one's genes. And that's true. That's true. However, the trauma of that event very well could have affected the epigenome, which in turn would have determined how the genes were expressed. You follow the thought here? The epigenome, so he was affected at the genetic level. It didn't change his genes. We have the same genes. We still have that same human DNA that Adam had, or at least very similar. But by having some alteration, or by having the trauma he experienced as a result of the fall, as it's called, then his epigenome could have well been affected, which then in turn would have made some changes in how the genome was expressed, or the genes in the genome were expressed, possibly even resulting in alteration in brain structures, the chemistry of the brain. I don't know. Again, some of this is theoretical, but at least I think the science itself, this emerging science, opens some doors and possibly sheds some light on some biblical topics. Some things the Apostle Paul seems to have taken for granted. Some things that seem to be taken for granted in Scripture, and that is that Adam's fall, his fall into sin, Adam and Eve, somehow affects us. Not only in the environment, the external environment, but possibly, again, this is theory, possibly in the internal environment. So it is possible that we did inherit a nature with a proclivity to sin from Adam as a result of the fall. Now, there are geneticists who basically agree with that. You know, experts in the field who know a lot more about this stuff than I do, or probably any of us in here do, who agree that that's a very real possibility. Now, I'd like to go back to Genesis 3 and take a look at the results of the fall and get an idea of what was going on there. Of course, you know the story. You know how the serpent enticed, the enticement of the serpent, how he led Eve to eat of the fruit that God told them not to eat of. Adam also ate, and of course they got in trouble as a result. This must have this was a traumatic experience. They right away began to change. Something about them changed. And in all probability, the trauma and the stress of the situation began acting on the epigenome, began acting on them internally. I'd like to go on to the what God said to them, starting in verse 16. To the woman he said, I will greatly multiply your sorrow and your conception. In pain you shall bring forth children. Your desire shall be for your husband, and he shall rule over you. Does this sound like something biologically may be going on here? A change, a biological change perhaps? I know there are different ways to interpret this passage, but if this indeed means that something is going to change as far as the pain you will experience in childbirth, then this is a biological change. And this is the result of the sin. And then to Adam he said, because you have heeded the voice of your wife and have eaten from the tree of which I commanded you, saying, you shall not eat of it. Cursed is the ground for your sake. In toil you shall eat of it all the day of your life. Both thorns and thistles it shall bring forth for you, and you shall eat the herb of the field. In the sweat of your face you shall eat bread till you return to the ground, for out of it you were taken, for dust you are, and to dust you shall return. Sounds to me like a situation very different from the Garden of Eden. Sounds to me like a new stress has come into their lives as a result of this sin. It sounds to me like they faced a major trauma here. And of course we know, at least the evidence indicates, that traumatic experiences in life affect the epigenome, which again, in turn, affects how the genes and whether the genes, certain genes, are expressed. So it is very possible that at this point, Adam's nature changed as a result of what we've been talking about here, and it is very possible that some of those changes, some of those epigenetic tags, were passed on to his progeny, giving them, therefore, a fallen nature. That's a possibility. I'm not going to be dogmatic about any of this. I'm just saying simply that this emerging science of epigenetics may shed some light on some things the Bible seems to take for granted, or at least seems to indicate. Now then, recently Wes talked about the lifespans of the patriarchs and how they grew shorter and shorter over time after the flood. He explained the canopy theory to you, which essentially states that there was a body of water, or there was a canopy of water encircling the earth, perhaps a very thick mist-like canopy, and that this is where the water of the flood came from. And that prior to the flood, the rays of the sun were filtered through the canopy, and then after the flood, because since that's where the waters of the flood came from, the canopy is now gone, and so human beings are exposed to far greater levels of radiation than they were before, and this, as Wes explained, may account for the descending life, the shortening of the lifespan for human beings. Well, my question would be then, how did that do that? How did it cause lifespans to get shorter? It didn't just suddenly happen, it happened over time. Well, I think the emerging science of epigenetics may shed some light on that. If indeed they're assuming that this theory is true, that human beings were exposed to greater levels of radiation, then it began to affect the epigenome. And when it affects the epigenome then acts upon the genes. Some tags wind up in places they ought not be. Some genes are turned off, other genes are allowed full expression. So there's a change in the expression in the genome, or the genetic expressions of the genome. And therefore, we can see how, very possibly, this contributed to a shortening lifespan and other physical changes in human beings. Now then, in Exodus chapter 20, if you take a look at that briefly, Exodus chapter 20, let's look at verse 4. God says, you shall not make for yourself a carved image, any likeness of anything that is in the heaven above, or that is in the earth beneath, or that is in the water under the earth. You shall not bow down to them, nor serve them, for I, the Lord your God, am a jealous God, visiting the iniquity of the fathers upon the children, to the third and fourth generations of those who hate me, but showing mercy to thousands, to those who love me and keep my commandments. So it seems that the children are affected by the father's sins. Now naturally, when the children repent of the sins of their fathers, if they no longer persist in their father's sins, then they're going to experience God's mercy. But what this is telling us here is that if they persist in the sins of the fathers, then God's wrath will continue to be on them. He will continue to visit them in that way. He will visit the iniquity of the children. Now, the question I have, though, is, well, the statements that I could make from this is, number one, it is quite possible that the children simply imitate the bad examples of their parents. I learned how to be an idolater from Dad, and I'm going to be an idolater too. It could be that. Or it could be that the children inherit some bad characteristics, some proclivities, that is to say, some inclinations, those that were developed in their parents as a result of long periods of idolatrous practice and other sins. Epigenetics opens the door to an explanation of how this may have happened. Generational curses may be explained by the emerging science of epigenetics. Ephesians chapter 2, certainly we see the Apostle Paul affirming that the devil certainly plays a role in the way this world is. But as you're going to see here in Ephesians chapter 2, he attributes the problems to the world to more than just the devil. The devil is involved, make no mistake about it. But more than the devil is at work here. Look at Ephesians chapter 2 and beginning in verse 1. And you he made alive who were dead in trespasses and sin. He's talking about converted people. People who have repented. People who have received God's Holy Spirit. And you, he says, he made alive who were dead in trespasses and sins, in which you once walked according to the course of this world, according to the prince of the power of the air, the spirit, that would be the devil, who now works in the sons of disobedience. So yeah, the Apostle Paul certainly gave the devil his due. Among whom also we all, now I want you to know notice the universality of the language here. We all once conducted ourselves in the lusts of our flesh, fulfilling the desires of the flesh and of the mind, and were, get this, notice that more than the devil is involved here, were by nature children of wrath, just as the others. Now the question I have is, how is it that we, and he includes everybody, we all once were like this, walking in the lust of the flesh. We all were by nature children of wrath. When God made Adam and Eve, do you think, when he declared, he said, this is very good, do you think he put a nature, a sinful nature in them? Oh, he gave them free will, that's for sure. But do you think that he made a nature that would rebel against him? One that had that proclivity? I would say the answer is no. The answer is no. I don't think that happened. And yet, here the Apostle Paul uses this language of this universalistic language, and he says that we all were by nature the children of wrath. How can he make such a statement? Unless something happened at the fall of man that changed the nature of human beings in some way and at some level. Well, let's go on over to Romans chapter 5. Romans chapter 5, and we'll bring this to a close pretty shortly. Romans chapter 5, and let's begin in verse 12. And I want you to notice in this text, again, the universalistic language. He's not saying that a few over here and a few over there turned bad, as our father Adam did, as our parents Adam and Eve did. No, he seems to apply this to the whole human race. He says, verse 12, therefore, just as through one man, that would be Adam, sin entered the world, and death through sin, and thus death spread to all men, not some, but all, because all sinned. For until the law, sin was in the world. Now, how does Paul know? How can Paul possibly know that everybody is a sinner? How can he possibly say that all have sinned and come short of the glory of God? He doesn't know me. It sounds like he does know me, but he doesn't know all of us. How can he say all have sinned and come short of the glory of God? How can he use this language wherein he takes in the whole human race, all of Adam's progeny, unless something changed in Adam's progeny a long time ago? Of course, we do know the devil is involved, but more than that, we know that nature, man's own nature, is involved, as Paul says. He says, for until the law, that's until the time of Moses when God codified the law, sin was in the world, but sin is not imputed where there is no law. What this means is sin is not imputed where there is no revelation of law. The law, law was always in existence. No question about that. Joseph spoke of sin. I show you in the case of Potiphar's wife, he called that, if he did what she wanted him to do, that would be a great sin. Many other cases in the Bible we see that God's commandments were enforced before the time of Moses. But the point is, what he's saying here is that just as Paul said in Acts chapter 17, what he's talking about here is the fact that throughout much of human history, between Adam and Moses, there was a period of incredible ignorance. People were not aware. Many people were not aware of God's law and had not received a direct revelation as Adam had not received a direct command, you shall not eat of this tree, or any other direct command. So there was a great deal of ignorance in the world. And the Apostle Paul in Acts 17 says that there was a time when he looked at all the idols in the city, and he spoke of past times of idolatrous worship all over the known world. He said that God winked at those things. What did he mean by that? He meant that they were in ignorance, so that makes a difference. Sin is not imputed the same way when you don't have a revelation of law as it is when you do know the law, when you do know better and you haven't grown up in ignorance and under deception. So that's what he's talking about here. For until the law, that is a revelation of the law, sin was in the world, but sin is not imputed where there is no law or no revelation of law. Nevertheless, death reigned from Adam to Moses. Even though these people were in their ignorance, death still reigned from Adam to Moses, even over those who had not sinned according to the likeness of the transgression of Adam. In other words, had no direct revelation, no direct commandment, you shall not eat of the tree of the knowledge of good and evil, or anything like that, who is a type of him to come. But so here he links Adam's sin, Adam's transgression, with the transgressions that would follow in the history that would follow, and even says that even though law was not revealed in a certain segment of human history to a significantly large population, nevertheless, death and sin continued to reign. Part of this, of course, was due to the devil's influence, but part of it was due to a change in the nature of man. Something happened, something changed when sin entered the picture. I say something changed in the nature of man, not only in this environment, but in the nature of man. Now, the science of the science that I'm talking here, this genetic science, epigenetics, is showing us that there is a relationship between the environment and the genome. As I said, we used to think years ago that the genome told the whole story. That you had good genes and you had bad genes. If you had bad genes, you were just unfortunate. Good genes, you were fortunate. Well, most of us have a combination of things that could lead to trouble and things that could lead to good things in our lives. But the question is how and whether those genes will be expressed. That's the real question. So if we have bad diets, if we have lifestyles like smoking habits and drinking habits and things like that, it will affect the epigenome and may well affect how the genes are expressed or whether they are expressed. And that will in turn have an effect on our health, which may well, in some cases, not every case, but in some cases, be passed on to our children and our children's children to the third and fourth generations and on down the way. So this is something to take into consideration, this emerging science of epigenetics, because it at least offers some possibilities on explaining how Adam and Eve's sin may be related to our sinful proclivities. As the Bible reveals, we do have sinful proclivities. But there's some good news in all of this. This relatively new science tells us that our lifestyle choices can also have a positive effect on how our genes are expressed. Some of these undesirable epigenetic tags can be stripped away. And some of these genes that might spell trouble for us down the road can be deactivated by simple lifestyle choices. If lifestyle choices can positively affect genetic expressions, I want you to think about this. Think of what the presence of the Holy Spirit might do. We now know that what we are is not entirely a matter of good genes versus bad genes. It's largely a matter of lifestyle choices and of how we deal with the burdens that we're called on to bear. And we have even much more than that going for us. We have the enabling power of God's Holy Spirit.